Right, on to chapter 7.1. It's going to start us talking off about electromagnetic waves, which is anything from the radio waves you listen to in your car all the way to gamma rays, with a stop in the middle of visible light. Again, remember that there is no difference between a microwave and the color red, except for the amount of energy in the wave, and that your eye is built to see this energy and not to see that energy. Alright, they're all the same thing. There are three primary parts to a wave, and they all tie back into each other. First one is wavelength, and that is abbreviated with the lambda. And all that one is if I have a wave, isn't it a beautiful wave? The wavelength is the distance from peak to peak, or trough to trough, or mid to mid. Okay, any of those will work. That is the wavelength. Second is the speed, and all electromagnetic waves go at the speed of light, which this year we're going to change from 3.0 times 10 to the 8th to 2.9979 times 10 to the 8th. More sig figs, more accurate. Okay, if I put those two things together, if I divide the speed of the light by the wavelength of the light, I get, and this is abbreviated C, I get my frequency, which is nu. Greek letter nu. Okay, and it will have the units of 1/seconds, because you have the speed of light, which is meters per second, and then the wavelength is in meters, and so you can cancel out your meters, and it's 1/seconds. Alright, so those are the three parts, and that's how often the wave occurs. So if I stare right here, and this wave moves this way, you can count 1, 2, 3, 4, how many times in 1 second it goes past. Alright, so if I want to convert between them, if I said that I had a red light with a wavelength of 650 nanometers, all I would have to do is take the speed of light, c, divided by the wavelength, and this would give me my frequency. So we'd go 0.29979 e to the 8th, divided, and that's meters, and it will be over seconds, divided by 6.50 e to the -7 meters. My meters will cancel out, so I've got my units for frequency, 1/seconds, which is what I want. So this has a frequency, a nu, of 4.61 times 10 to the 14th, and instead of writing 1/seconds, we put hertz. That's what hertz means, 1/seconds, for the units. Okay?